Student Scholars in association with Goa Headmasters Association.
Welcome students for the third session of chapter triangles. We have already done 2 sessions of this, and if you've not watched those videos, then I would highly recommend that you go and check those videos out, because all what we are going to study today is in continuation of what we have learned in those 2 classes. So we had stopped on chapter triangles where we saw riders, and one rider was already done, second one was in the progress. So I'll recap what we had done in the previous class. So in triangle ABC, AB is equal to AC, AE is perpendicular to BC, and D is any point on BC. Prove that AB square minus AD square is equal to CD multiplied by BD. Let's draw the figure. So triangle ABC, and we know that AB is equal to AC. Now E is some point, and we draw a perpendicular, alright, and D is any point on the side BC. So what are we asked to prove? We are asked to prove AB square minus AD square is equal to CD multiplied by BD. And if you have not watched those videos and still want to get back to this only, then the proof that itself tells you that, from which theorem is this rider about. So you need to know we have done already 4 riders, 4 theorems, and from those theorems is what you will derive this rider. So consider these 2 triangles now, which is AEB and AEC. So I have written that. Then E is perpendicular, right? So the point E was perpendicular to BC. So we can write angle AEB is equal to 90 degrees. Based on that, we can say that AE is perpendicular to BC. Next, what we are going to do is we are going to consider those 2 sides. If you can notice that they are blinking now, that is AB and AC. So I'll write AB is equal to AC. It is given to us. Alright. Next, I can say that AE, the side AE which is there, is common to both these triangles. And once it is common, I can write AE is equal to AE, saying as common side. Now I have 3 pieces of information. In class 9, you have already studied, when I have 3 set of information together for a triangle, I can say that these 2 triangles are congruent. And if you can try guessing which test it would be there's a right angle there, there's a hypotenuse involved, and there is another side. So I can say that triangle AEB is congruent to triangle AEC by RHS test. Okay, so next, once we are done proving that these 2 triangles are congruent, there is something else that we can say about these 2 triangles, and that is, if you look at the figure, it is this side, that is BE and EC, both of them will become equal, and it is because of CPCT. CPCT is nothing but it is telling you that it is corresponding parts of congruent triangles. Okay. Next, what we are going to do is we are going to look at triangle AEB and write Pythagoras theorem for it. We have already studied Pythagoras theorem in the proof that we had done. So it is nothing but hypotenuse square is equal to sum of the other 2 sides of the triangle, the arms of the right angle, you can say. So it would become AB square is equal to AE square plus BE square. Okay. Next is we are going to look at that red color triangle and try to write Pythagoras theorem for that triangle as well. So that would be something like this. Okay, so I have AD square, which is the hypotenuse for that red color triangle, is equal to AE square plus DE square. Now if you look at step number 6 and step number 7, there's a side which is AE common, right? So all I'm going to do is, in step number 6, keep AE square on one side and bring all the other terms on the other side. Okay, I could have done it in step number 6 directly, but then you would wonder like, how is this Pythagoras theorem relating to? So that's the reason I wrote the Pythagoras theorem in its normal form first, and then all what we are going to do is transpose these sides exactly how we want it. Okay, so this would become, I'll keep AE square on one side, so what I want to move is BE square, right? Step number 6 is what we are discussing. So BE square is positive on this side, so if you throw it on the other side, transpose it on the other side, it would become minus BE square, and you would get something like this. Okay, so AB square minus BE square is equal to AE square. Same thing we are going to do for step number 7. So can you analyze it now by yourself? 2 seconds to think about. Okay, and I hope that you are already done thinking about it. Okay, so it would be something like this. Now if we look at step number 6 and step number 7, all what we can do is, the right hand side is the same, right? So I will equate both the left hand side in step number 8. Doing that, it would be something like this. Okay, and from where did we get all this information? We got it from step number 6 and step number 7. So all I have done is try to equate the left hand side. Now if you look closely at step number 8, you will realize that, okay, let us try and look at it in terms of the figure. So AB square is the hypotenuse of a triangle. BE square is just a regular side. AD square is again a hypotenuse of a triangle, and DE is another side. So what we are going to do is put the hypotenuse terms together and the other sides together. So this would become something like this. So AD square, which is on the right hand side, which is positive, you throw it on the left hand side, it would become minus AD square, right? So this is what will be my step number 9. So what we have done, just transposed the hypotenuse on left hand side. Now if you look at step number 9 and what we are asked to prove, you will realize that the left hand side is already done. Now all we have to concentrate is on the right hand side. So we are halfway through in proving this entire rider. So, and again, another tip for you when you're solving riders, please make sure that you are checking what exactly is going on, because you will, as you're solving certain steps, I would recommend that you go ahead and check what are you exactly asked to prove, because if you don't do that, then you'll end up just solving something or the other randomly, and then you will not know where exactly you're reaching. So check where exactly you are and then go ahead. Okay, so I have done AB square minus AD square, right? So that till here it's done. Now the right hand side, what you can see is BE square minus DE square, right? So here if you look carefully, it is nothing but like A square minus B square, kind of that way. So I could write this entire right hand side as A plus B, A minus B. Okay, so what I would do over here is I would write the step 10, keeping left hand side as it is, but changing the right hand side into two brackets of A plus B and A minus B. From where did we get this? Entirely from step number 9. Okay, now look at step number 5. Okay, I've already highlighted it for you. It is telling me that BE is equal to CE, correct? Now wherever BE is there, all I'm going to do is replace it with CE, and if I do that, it would become like this. Okay, so BE is replaced with CE, DE is kept as it is, and the other bracket, though I was saying that we will replace BE with CE, but I've still tried keeping it exactly the same. Now that will be a question like, so this idea is only because, like, look at the figure. If you take BE as one of the side and DE is a part of it, if I minus those two, I can get some result. But if I don't, and if I would put CE in place of BE, you would realize that CE is completely another part of a triangle and DE is another part. Even if I add, if I subtract it, there is no result that's going to come. That's the reason I've kept that BE as it is, okay, and just change it over here. So if you look at the figure now, okay, so the left hand side is kept as it is, and here CE is, you can see at the figure that CE is become red in color and DE is also become red in color. Together it is nothing but entire length of the side DC, right? So the first bracket DE plus CE gives us the answer as CD, okay? The next bracket what we are going to look at is BE. Look at the entire stretch of BE, which is blue in color right now, and I am minusing DE from there. So let me remove that. So if I remove that DE, what am I left with? I'm just left with the length of the side BD, right? So I will write BD over here, okay? And if you look, what are we asked to prove is we are already done with that entire proof. So I hope you have been able to understand, not just the theorem or the rider, but the logic behind what steps we take, because you can take different steps to come to this conclusion. It's your choice, but as long as they are mathematically correct, it is just right, okay? So there is no exact recipe, as I was telling you in the earlier class. You need to understand what you want to do and then go ahead taking mathematical steps, not just randomly multiplying anything anywhere. So I hope this is clear. If you want to take a screenshot right now and copy it later, you can. Or if you want to get back to me with certain questions, my QR code is there for the YouTube channel. You can go ahead, check that out, or you can write an email or Instagram message as well. Let's go ahead for the next proof. PQRS is a rectangle. C is any point in the plane of the rectangle. Through C, a line AB is parallel to PS, meeting ray PQ and RS at A and B. Line CD is parallel to PQ, intersecting at QR at D. Prove that this. Okay. So there's so much of information. Again, without a figure, it's very difficult to understand. So first of all, let's draw the rectangle PQRS. Okay, this is done. C is any point in the plane of rectangle. What does it mean? If I have a plane like this is, if I draw a PQRS on my hand, then on plane of PQRS means it is exactly on the hand itself. I can't draw a point over here and say that it is on the same plane. This would be on two different planes, right? So point over here would be considered on the same plane. So like that, C is some point, alright. Then through this point C, a line is being drawn. What is the name of the line? AB, considering that it is parallel to PS. So something like this. Name of the line will be AB. Then those PQ and SR are joined to that point AB and you will get a figure like this. Okay. Then next thing they are telling you is that line CD is parallel to PQ. So we would get a figure like this. Okay. And till here is what information is given to you. But if you look closely at what we are asked to prove, they are talking about side CQ square. But I have not drawn any CQ, right? So all that we have to do is join CQ. Similarly, there is CS also where it is not drawn. So all that we are going to join and you're going to get something like this. And all those who are watching this video right now must be wondering, any keso proof korpacho or sodia. And most of y'all, students, whenever they look at the riders, they get scared looking at the figure itself and just forget about everything, and then they stop, they start hating triangles actually. But I'm here to tell you that you need to love triangles and get them done very easily. So just know what exactly you need to do first, and then it will become simple. And practice a lot of riders. So since AB is parallel to PS, this was already given to us, okay, and APS is equal to 90 degrees. Now because we are told that PQRS is a rectangle, we know all this information, right? So AQRB also becomes a rectangle. This is based on all the information that we have in the figure and our understanding of what are the properties of a rectangle and so on. So from here I can write this, right? AP is equal to BS. So whenever you have a rectangle, the opposite sides are equal. You already know it. Same way I can write AQ is equal to BR, which will become red in color right now. Okay, this one. So this is all information that we could interpret from whatever was given to us. Okay, next what we are going to do is, this is from step number 1, though I have not written step number 1, you can write step number 1 over there. Okay, now look at this triangle. Okay, triangle is QAC. Okay, for this triangle I can write Pythagoras theorem, which would be hypotenuse square is equal to square of the other two sides, right? So here my angle A is 90 degrees because it's a rectangle, and so I can write this as Pythagoras theorem. So reason would be Pythagoras theorem. Okay, next what I'm going to do is look at this triangle now. Okay, so it is CBS. In this triangle also I can write again Pythagoras theorem, and it would be something like this. Okay, reason would be Pythagoras theorem. Next what we are going to do is we will try and equate certain things. So here what we have done is we have added step number 3 and step number 4. Okay, and if you look, why have we done that suddenly is because look at step number 5, the left hand side CQ square plus CS square is added, right? And if you look at what we are asked to prove, we are already done with that left hand side. Now all what we have to bother about is trying to prove right hand side. So it's basically that simple. You just have to concentrate what you have studied based on the proofs and then try and solve this. Okay, so this would become left hand side is just added, right hand side whatever was there is put down together. Now we are going to slightly adjust here and there to get my right hand side as well. So in step number 6, right, I have written exactly the same thing. All I have done is tried to replace AQ, I'll just show it to you here. AQ is equal to BR, right? So in that step number 5, wherever AQ was there, I have written BR, and since AQ square, I have written BR square. Same way, okay, this is what we got here. I have AP is equal to BS, right? So wherever there is BS, I have replaced it with AP. Okay, step number 2 and step number 5. So step number 5 is just helping us to write the entire thing again. Step number 2 is helping us to replace the terms. Okay, now step number 6 is just adjusting here and there, and what I've done is AC square is exactly in the place where it was. AP square I've just moved from the last term to second term. Now you'll ask me, like, how do you realize suddenly you have to move the steps over here? If you look at the figure back again, you will realize that AC and AP are nothing but part of that same triangle. Whereas if you would look at AC square and BR square, they are different parts of different triangles, right? So I'm just trying to get same things together. It's like, you know, birds of the same feather flock together. So trying to get the same terms together. And that's how I have written AC square plus AP square together. Same way, BR square plus CB square. Okay. Now, look at this triangle back again. If you realize that AC square is one side of the triangle, okay, AP square is another side, and when I add, I can use Pythagoras theorem to write both of them sum as CP square, because that's how Pythagoras theorem tells us that, right? So all I will do is write AC square plus AP square as CP square, and BR square plus CB square will be a part of this entire big triangle. Okay, so I've added them together, and that's how I got CR square, and that is what was asked from us to prove. It's that simple. So just all what we have done is used Pythagoras theorem, nothing else. It is, you know, so simple. But only thing, if you practice only, then you will be able to, you know, try and understand what exactly to do when you're solving these problems. Let's try another problem. I'm sure you want to try one more rider, right? So let's go ahead and do that. In this proof, what we're going to learn, or in the rider, is that ABC is a triangle and angle B is right angle. Point X and Y trisect BC. Prove that AC square plus 2AY square plus 3AX square is equal to 6AB square plus 20BX square. Now from that, you know, the simplest rider to a very complex one, there's a transition. So I wouldn't say this is completely, you know, difficult one, but if you just look at what you are asked to prove, it looks that, you know, it's going to blow your mind that way. So, but it is going to be a simple one. So let's draw the figure first. Alright, so here I have a triangle ABC. B is right angle, so I've marked over there. Next, if you realize that they have said X and Y trisect BC. So first of all, you should understand what is the meaning of trisect. If I would say a line is bisected, means it is cutting it into 2 equal halves. If I say trisect, I'm going to cut it in 3 equal parts. That is all what it means. Okay, trisect. So X and Y. Okay, now I will write. Okay, I'll just join this. Why am I joining all these points? Is because I'm asked somewhere that is AX is used. So if I don't join it, then AX is, there's no line itself, right? So I've just joined them. And BC is equal to 3 times BX. Now what does this mean? I told you when trisect word is used, it is just telling you that you are joining the line or cutting the line in 3 equal parts, right? So BC, that entire line, look at that entire line BC, and I can refer it as something like this, 3 equal parts, right? And so 3 parts equally will make up the entire line BC. That's the reason in the first part we have seen BC is equal to 3 times BX. Next, I will say BY. Now look at till the position BY. Okay, so BY is 2 times BX. Okay, so I have done that. I hope this part is clear why we write step 1 like that. Okay, next what we are going to do is, this is given. The simple statement that it is telling us that X and Y trisect means this much. Okay, now look at the entire triangle ABC and let us write Pythagoras theorem for it. So for this, Pythagoras theorem would be AC square is equal to AB square plus BC square. Okay, now in that figure or in the statement we have BC, and look at step 1, there's also BC over there, right? So all we are going to do is try and replace it. So first we will write Pythagoras theorem and we will say AC square is equal to AB square plus 9BX square. How did we come to this conclusion? All I have done is from step 2, wherever there was BC, I have replaced it with 3BX. Now there was a square, right? So 3 times 3, so 3 square will become 9 and BX will become BX square. Okay, that's all. So from which steps? Step 1 and step 2 exactly. So I'll not write anything, I'll just keep it that way. Now look at this triangle. Okay, this triangle is nothing but ABY. So let us write Pythagoras theorem for this one as well. It would become, okay, AY square is equal to AB square plus BY square. Now all I'm going to do is look at step number 1 and step number 3. Wherever there is BY, all I'm going to replace it with 2 times BX and it would become, so 2 square will become 4, BX will become BX square. Okay. Next, in the 4th step, all I will do is multiply it by 2 throughout that equation. Now, In the second step, I have not multiplied anything, but in the third step, all of a sudden, I'm multiplying by 2 throughout the equation. Why? Is because if you look at what we are asked to prove, we want something as 2ay square, right? So unless and until I multiply 2 to that, I'm not going to get any, there's no other way that I can just get 2ay, right? So I can't multiply 2 only in one place. If I would do that, then the entire meaning changes. So we have to multiply it throughout that equation. So that's how I get 2ay square multiplied by 2ab square plus 8bx square. Okay. Next, we are going to write Pythagoras theorem for this triangle as well. So it would become ax square is equal to ab square plus bx square. Again, hypotenuse square is equal to sum of the other arms of that right angle. Okay. Now, in that, prove that we want 3 times ax square. Now, can you guess what we'll have to do over here? Yes, you are right. You have to multiply by 3 throughout that equation, and it would be something like this. Okay. So it will become 3ax square is equal to 3ab square plus 3bx square. Okay. Now, look at all these terms, all whatever is highlighted in green. So ac square, 2ay square and 3ax square is what is there in that proof on the left hand side, correct? So all what we'll do is we'll just add them together and we are done with the left hand side, right? So adding it would be something like this. Now whatever same terms are there on the right hand side, we'll add them also. So this would become, look at all these terms highlighted now. So I have ab square plus I have 2ab square plus I have 3ab square. It is just like, 1 chocolate, then 2 more chocolates and 3 more chocolates. All of them together how much? So 3 plus 2 will become 5, 5 plus 1 will become 6ab square. Correct? Now look at the next part. Okay, all these. Okay, so I have 9bx square, and then 9 chocolates, plus 8bx square, 8 chocolates, and 3bx square. So add all of them together and you would end up getting 20bx square. And that is what is asked from us to prove. I hope you have understood and clear with this rider. It's that simple. If you want to write this thing down, you can take a screenshot and then copy it later. But please do try these riders. Given in triangle ABC, D is a midpoint of side BC, D is perpendicular to AC, at E also EA square minus EC square is equal to AB square. Prove that ABC is a right angle. Okay, so let's draw a figure first. So I have a triangle and then ABC. D is a midpoint. So once I mark that D, the other parts DC and DB are equal. So I've done that. Okay. E is perpendicular. So I'll just draw a perpendicular line. And you are asked to prove EA square minus EC square is equal to AB square. Okay, this is also given to us. B is a right angle. That is what we are asked to prove. So, in right angle triangle AED, the one which you can see in red, okay, I can write Pythagoras theorem and it would be AD square is equal to EA square plus DE square. Now, whenever you look at triangles, right, which are not in a normal way of presenting a right angle to you, keeping that right angle at the base, sometimes it becomes very confusing which is the hypotenuse and which is the longest side, right? So, all I will request you is try and locate the right angle first and the side in front of that would be hypotenuse. So, technically, I'm sure you must be also thinking like, that D looks to be a right angle and AE square should be what it is. But it shouldn't be like that. You have to locate the right angle first and then the other side. Okay, the hypotenuse. So this would be AD square is equal to EA square plus DE square. Okay, next, this is from the Pythagoras theorem. Now, all I have done is kept EA on one side and brought rest of the terms on the other side. Okay, and if I would write it directly like this, then again you would be in a confused state of mind, how did I get this as a Pythagoras theorem? All the time, I'm continuously telling it is sum of the sides, and suddenly how there's a minus sign involved there. So all I'm doing is replacing it afterwards. Now why did I do that? If you look what is given to us in the question, right, there again there is an EA square over there. So what I want to do is try to transpose those terms on the other side so that I can equate it. We'll see it in the next steps. Okay, but it is given to us that EA square minus EC square is equal to AB square. It is given in the question. Okay. So I have written that step, adjusting EA square on one side and bringing all the terms on the other side. Now, in the first step also I have EA square equal to something. In the second step also I have EA square equal to something, right? So let us equate step number 1 and step number 2. So when I do that, it would be something like this. AD square minus DE square is from the step number 1 is equal to AB square plus EC square is step number 2. I have just equated them. From which steps? 1 and 2. Next, what I'm going to do is keep AD square on this left hand side only and take DE, which is on the left hand side, and throw it on the right hand side. So when you transpose a term negative from the left hand side to right hand side, it will become positive. So sign changes, right? Step number 3, just moving one step to the other. Okay, look at this now. EC square plus DE square. Look at it in terms of, at the figure. It is a part of this triangle that you can see, and E is a right angle. So instead of writing those two terms, EC square plus DE square, all I can do is write CD square, which is the hypotenuse. Right? So this entire thing will be replaced with, I've written the same step back again, and now I will change it to CD square. Okay? Now once I have done this, if you look in the given that was there, D was told to be the midpoint, right? So CD and DB are equal. So wherever we have CD, I can replace it with DB over there. So this would become, look at step number 5, right? So I can write step number 7 as exactly as step number 5, but all I'm doing is replacing the CD with DB, so it would become DB square. And if you look at step number 7 now, and look at it in terms of the figure. So AD square, okay, is equal to AB square plus DB square. And in the theorem, that is converse of Pythagoras theorem, we have learned that if this condition is satisfied, then there should be a right angle over there. And that's how I can conclude that ABC is a right angle by converse of Pythagoras theorem. I hope you are clear with this. If you want to take a screenshot, you can go ahead, do that. And I think we are done solving too much of riders, right? So let's, solve a different kind of question in this. Okay? And these are nothing but fill in the blanks that can be asked for your board exam. Okay? So you are told that ABC is similar to triangle XYZ. Okay? It's already told that it's similar. If ABC is equal to 25 centimeters square, that means the area of that triangle, and area of triangle XYZ is given to us as 64 centimeters square. Then you are asked BC upon YZ is equal to how much? Does it give a very similar thing to that proof that we had studied, a result? If I'm sure you must have forgotten by now. If you have forgotten, then just take a recap of that. Okay, so we had studied this theorem, right? We had said that if the ratio of their areas of two triangles is equal to square of the other two sides. Yeah, you got it. Okay, so let's write it down now. This is normally what we can understand from the proof. So AB square upon triangle XYZ, area of triangle XYZ. Okay, no, sorry, area of triangle ABC upon area of triangle XYZ is equal to square of the corresponding sides. So I have taken BC upon YZ the whole square. So let us substitute the values now. ABC is 25, so I have all this information, and XYZ is 64, correct? So is equal to BC upon YZ. So but are we asked BC upon YZ the whole square? No, we just asked BC upon YZ, right? So what we are going to do is take root on both the sides. So if I do that, square root of 25 will become 5, square root of 64 will become 8, and BC upon YZ square root is square root, and the square will get cancelled, and what I will be left with is BC upon YZ, which is 5 upon 8. Let us solve another problem. So triangle DEF is similar to triangle XYZ. Okay, if DE and XY is to the ratio of 5:2, area of triangle DEF is 70 centimeter square, then area of triangle XYZ is equal to how much? So here there is another way of writing the the ratio. Initially when I started with this chapter, I was telling you that there is a ratio can be written in different types. The best one to remember is numerator upon denominator, because you comprehend it well, but it is another way of writing a ratio. So all I have done is written the understanding of that entire theorem, and let us substitute the values afterwards. So DEF was 70, area of triangle XYZ is something that we need to find out. Sides are already given to us. So squaring it would become 70 upon area of triangle XYZ is equal to 5 square will become 25, 2 square will become 4. So all I'm doing now is cross multiplying, so that XYZ, which is on the left hand side in the denominator, when you throw it on the other side of equal to, will become multiplied, right? So it goes in the numerator there, and 25, which is the numerator, on the other side of equal to comes down as denominator. So if you do all that calculation, you will get 11.2 as the area of triangle XYZ, and which is one of the option in that fill in the blank. Okay, so here I have another one. PQR and ABC are similar. If area of triangle PQR is 27 and area of triangle ABC is 75, and BC is equal to 10 centimeter, then QR is equal to dash. So again, the understanding of the entire proof is written there. All I have done is try to solve it the same way. One important thing to keep in mind is that, just look at the mouse pointer. Okay, whenever you're writing this ratio, please make sure that this side which is there is a part of this triangle. That means I'm writing QR and the area of triangle PQR. I'm not writing QR over here and writing ABC in the numerator. That would be wrong. So because there are times when a problem like this is given, but when they are asking you the ratio, they will purposely write it as BC upon QR. So you need to keep in mind that when you are writing the side, the exact way, the other side would be the triangle also. It can't be a different triangle. So based on that, you do all this calculation and you would get 36 is equal to QR square. But we are asked only for QR. So all I have to do is, now 36 is nothing but 6 multiplied by 6, and QR square is QR multiplied by QR, right? So QR is equal to 6. And some of the students might be already thinking like, what is this? Why this has to be discussed? It is for those students who have no idea what happens, when you take a root and all. So for those students to understand. If you have understood it, good enough. Okay, so QR will be 6. Another one. ABC, okay, in this triangle, P and Q are points on AB and AC respectively, such that PQ is parallel to BC. If AP is 12, PB is 8, AQ is 9, find length of AC. So it is based on this theorem, and the question is something like this. So PQ is some point. We know that if PQ is perpendicular to BC, I can write the ratios. So whatever information was given is put it in the figure, and it would be something like this. Okay, so QC is in the denominator, throw it on the other left hand side and take it in the numerator. So this would become something like this. 8, which is in the denominator, goes on the other side, gets multiplied and divided by 12. After calculation, you got QC is equal to 6. But wait a second, are you asked length of QC there? No, you are asked length of AC, right? So look at that figure back again. What we have got is this distance, QC, right? But we are asked AC. So AC is nothing but AQ plus QC, which is 9, which is already given to you, plus 6, what you have calculated right now. So the length is nothing but 15. So these are ways that these questions can be asked. Sometimes, they directly ask you the length of QC. That's a very easy kind of a quest, fill in the blank. If they want to slightly, make you scratch your head a little bit more, then they will ask you questions like this. And since students don't solve all the type of fill in the blank, they just read and say like, okay, done, done, done. That's when these problems arise. So very important, figure. Please draw a figure, and draw a figure in the rough column at the size that you can actually see it, because I have also observed students drawing a figure this small, where they also don't know what is Q and what is B, and gone then. So please keep those things in mind and you'll be able to solve. So if you want, okay, this is a different one here. DEF is similar to XYZ if 9 times area of triangle DEF is equal to area of XYZ. D is 1.5, then XY is dash. Here there's no ratio given, but you can derive the ratio from this statement. So I've written that entire step again for you. So what we are going to do is this. We'll get area of XYZ down and get area of DEF in the denominator. 9 will remain as it is. So if you don't write anything over here, it is understood that there is 1 over here. So 9 upon 1 is nothing but this ratio, right? But since the triangles are similar, this is a normal understanding. The ratio of their areas is equal to square of their corresponding sides. So based on that, instead of writing this entire thing in red, all I can do is substitute 9 upon 1. Okay, so that is done, is equal to xy to whatever is there, I've written as it is. So xy is something that we have to find out. So all I will do now is take this 1.5 and multiply this side. But wait a second, how come 1.5 is written twice over here? Is only because there is 1.5 the whole square, which means 1.5 multiplied by. So I'm not taking a square root right away. So I'll just transpose that 1.5 twice multiplied on the other side. So after calculating this, you will get 20.25 as xy square, and taking a root over there will become 4.5 into 4.5 is 20.25. Okay, and that's how you get the answer to be 4.5. Okay, so let us recap all whatever we have studied in all these 3 sessions, and what was important in the first session that I've told you was how do you tell that a figure is similar. It has to have same shape and different sizes is okay, right? Next, the different tests which prove that triangles are similar, okay, and that was AAA similarity test, which is also known as AA similarity test also. Side similarity test, when the ratios of all the one triangle are equal to the ratios of the other triangle. And SAS test, that means 2 sides of one triangle are equal to 2 sides of the other triangles in their ratios, and the angle between them is equal. So that will be called as SAS similarity test. We learned this theorem that when a line is parallel, the other sides are in the ratio. We also learned this theorem where the triangles, if the areas are in the ratio, then the square of their corresponding sides are equal. We learned Pythagoras Theorem, which tells the square of the hypotenuse is equal to sum of the square of the other two sides. I told you how to locate the hypotenuse as well. We learned the converse of the Pythagoras Theorem, where we said that condition of Pythagoras Theorem, the square of the hypotenuse is equal to square of the sum of the other two sides, is possible, then automatically the angle becomes right angle. Okay, and in case you have any questions with regards to this chapter, triangles, and you want to get back to me, this is a YouTube channel that you can go through, Math World, and thank you very much. That's my QR code for the YouTube channel. Also, the email ID and the Instagram account. So just message me if you have any doubts, and I'd be happy to answer them for you. But please, once again, I'll just tell you that don't send entire rider and tell me just to solve it. That's not possible. You send a screenshot of what you have done to prove that, and then I'll be able to help you out, solving it for you. So thank you very much. Thank you for listening all this throughout the session, and God bless. May you love maths and may you love liking triangles as well. Bye-bye.